Assalamu alaikum. My name is MD Mazal Islamunta, ID 171351844. A logic of authentication. Authentication protocols are the basis of security. Basic notation and logical postulates are used to define protocols. Every protocol contains some messages, and in this paper, protocols are idealized before analysis. And at last, every message of the protocol concludes a decision. So, in this paper, author said that there is a good communication between A and B. If there exists a shared key, then the outcome should be like that. A believes there is a shared key between A and B believes there is a shared key between A and B. Also, A believes that B believes there is a shared key between A and B believes that A believes there is a shared key between A and B. So these are the standard output. So we have logical postulates, message meaning. For shared keys, if there is a shared key between Q and P, and if P believes that, and if P sees there is a statement X encrypted by K, then we say that P believes Q said X, that is, the statement X was sent by Q to someone. For public keys, we have this rule: P believes the public key of Q and P sees the statement encrypted by the secret key, then we can say that P believes Q said X. For shared secrets, we have, if P believes there is a statement Y, and if this is shared between Q and P, and P sees the statement X combined by the statement Y, then we say that P believes Q said X. Nonce verification rule: if P believes that the statement X is fresh, that is, the statement X was not sent to anyone before, it is totally fresh, and if P believes that Q sent the statement X, then we can say that P believes Q believes X. So we have the jurisdiction rule: if P believes that the statement X is controlled by Q, that is, Q has the full jurisdiction over X, and if P believes that Q believes X, then we can say that P believes X. If a principal sees a formula, then he sees its components also, and for example, we said that if P sees the statement XY, then he also sees the statement X. If one part of formula is fresh, then entire part must be fresh. If P believes fresh X, then he also believes fresh X and also Y. So I have the Kerberos protocol. Now I will discuss about it. In this case, there is a authentication server S, and at first a request server is that he wants to communicate with B. Then server returns a message containing the ticket of B, and when A gets the ticket, in third message A passes the ticket to B. Then if B is satisfied with the ticket, also in the third message A passes its timestamps also, and if next if B is satisfied with the ticket, then B returns the timestamp of A and ensures that B wants to communicate with A. So here are the messages I have discussed already here. So before analysis, we have the idealized protocol for message 2, message 3 and message 4. Assumption: we have got some assumptions which are very important when we are going to apply our rule to any messages. Then we need these assumptions also. For example, A believes that there is a shared key between A as or A believes a phrase timestamp of uh, server, B believes phrase timestamp of server, B believes phrase timestamp of A, etc. So message 2, after analyzing message 2 concludes that A believes there is a shared key between A and B. Message 3 concludes um, that there are two parts in the message 3. One part concludes that B believes that there is a shared key between A and B, and another part concludes that B believes that A believes there is a shared key between A and B. So message 4 concludes A believes that B believes there is a shared key between A and B. So these conclusions reflect the um, author's desire. So we can say that what authors desired, it happens here. There is a good communication between A and B. There is a weakness, replay text at the time of clock synchronization, as it is based on clock synchronization. So here is the proof for message 2. We have used here our assumptions and postulates to prove the message 2. So after analyzing, we can see that we have got A believes that there is a shared key between A and B. We also have a proof for message 3, and we also get here the conclusion. B believes that there is a shared key between A and B. So we have a proof, and there are two parts of message 3, and for the rest part of message 3 we got this. B believes that A believes there is a shared key between A and B, and also we have applied message meaning and nonce modification rule to message 4, and we have got this. A believes that B believes there is a shared key between A and B. So I already discussed about Kerberos protocol. So in Kerberos protocol, we have seen that shared keys are established between two principals with the help of authentication server, and timestamps are used to eliminate security problems. The protocol relies heavily on the use of synchronized clocks. So there are three other protocols which has been discussed in this paper. So Secure RPC handshake protocol, and Nidam Schroeder public key protocol, CCITT X.509 protocol. So Kerberos protocol, we have got four conclusions which ensure that authentication is complete between two principals. It is based on synchronous clocks, so replay attacks may happen while synchronizing of principal clocks with server clocks. In terms of RPC, when it comes to fourth message, it doesn't believe to be fresh. That's why an intruder can easily convince A to use compromised session key. In terms of random Schroeder public key protocol, middle attacks are happened in this protocol in such way that an intruder pursues the principal A to communicate with him, and then the intruder communicates with B as though B is communicating with A. And in terms of CCITT, we got weaker outcome, as we fail to obtain B believes A believes something, or A believes B believes something, and an intruder can easily attack the system. So I think Kerberos is better than other three. So thank you.